Hello, a very good evening to all, and welcome to my class. So, basically, today, what we are going to do now, we are going to solve numerical and revise the concept that we studied in our previous week, right? So, we are going to revise all the important concept, important formulas, important theory that we were discussing in the previous week, right? And on this topic only, we are going to solve some numerical that's really important to understand the entire concept. Okay, so let's start with the today session, today class. Join, all of you, please join, and then we're going to start quick revision for this entire week, and after this we are going to solve numerical on this topic, right? So I'm audible, my screen is visible to you all. Yeah. Okay. So let's start with the quick revision. That is, we all know about the ideal solution, right? We are already discussing in our previous class about the ideal solution. So we all know the ideal solution are those which obey Raoult's law over the entire range of the concentration. And there are some characteristics of an ideal solution like enthalpy of mixing for ideal solution is equal to 0, delta V of mixing for ideal solution is 0, and delta G. So delta G always also comes out to be negative, right? So these are the some important characteristics of ideal solution. It means any solution which follow Raoult's law is known as ideal solution. Okay. Now, examples of ideal solutions are benzene, toluene, N-hexane and N-heptane, ethyl iodide, ethyl bromide, chlorobenzene, bromobenzene. They all are the example of ideal solution. I'm just revising this because we already discussed this thing in detail. Okay. So here I'm just revise this all for you so that you can remember this, and from above this topic we can uh, solve numerical based on this theory or topic, right? So let's see the graphical representation of ideal solution. So we also represent ideal solution by using the curve, and this curve between mole fraction and the vapor pressure. Mole fraction is taken along the x-axis and vapor pressure is taken along the y-axis. So this is the curve between the mole fraction and the vapor pressure. So what the curve indicate that beta? We know that according to the Raoult's law, that is Pa is equal to P naught A multiply by XA, right? So PA is nothing but PA is equal to P naught A multiply XA. Similar, what is PB beta? So PB is nothing but it is equal to P naught B into XB. What is this PA and PB? This PA and PB is the partial pressure of the each other. And what is P naught A and P naught B? So P naught A and P naught B are the vapor pressure of the pure state. It means, what do you mean by the pure vapor pressure beta? It means when they are alone. Now when you mix these two liquid, then we got the partial pressure, which is represented by Pa and Pb. So P naught A and P naught B represent the pure vapor pressure of a liquid A and B, and Pa and Pb represent the vapor pressure, partial vapor pressure, when these two liquid mix with each other, right? So we know that according to the straight line curve, that is y is equal to mx plus c. So this is the equation of the straight line, right? So this is the equation of the straight line. So by using this equation only, in the y-axis we are considering pressure, and x is a mole fraction and m is the slope. So by using this equation y is equal to mx plus c, we can draw the curve like this. So this is for A, this is for PA, and this curve is for PB, right? And this one, that is P naught A and P naught B. On matching these two lines, we get PT. So what is PT here, beta? So we get PT is equal to total pressure is equal to PA plus PB. So this is how we'll get total pressure. Okay. So I hope this is clear. How will you represent ideal solution with graph? Okay. Now, what is the non-ideal solution? So basically, non-ideal solution are those which do not obey Raoult's law over the entire range of concentration at a given temperature. Or we can say that in which PA is not equal to P naught A into XA, and PB is also not equal to P naught B into XB. For such mixture, delta H of mixing is not equal to 0, and delta V of mixing is also not equal to 0. So a non-ideal solution show the following two types. Obvious, if PA is not equal to P naught A XA, PB is not equal to P naught B into XB, then what? either it will be more than this or it will be less than this. Only two options arise, na beta. Either it will be more than this or it will be less than this. So upon these two category only, we classify non-ideal solution into two types. That is positive deviation and the negative deviation. It means the solution which show the positive deviation. It means they show vapor pressure. They show more vapor pressure than what we expected from the Raoult's law. जितना हम लोग Raoult's law से expect कर रहे थे, अगर उससे भी vapor pressure ज्यादा आ जाता है, then we can say it show positive deviation. Now, if they show, if we expect pressure and it comes out to be less than what we expected from the Raoult's law, then it will show negative deviation. So two possibilities maybe arise. Either it will show positive deviation or it will show negative deviation. So let's see, when we see positive deviation and when we see negative deviation. So solution showing the positive deviation. So the vapor pressure of each component in such a mixture is more than what would be expected of from the Raoult's law of component A and B alone, right? So this is called the positive deviation. And what is the possible reason behind this, beta? Yes, if the attraction between the AB molecules, for example, let me show. This is liquid number A and this is liquid number B. Okay. So these are the liquid in its pure state. A liquid is the force of attraction between the liquid A is solute, that is AA, and in B there is BB. When these two liquids are mixed with each other, then a new kind of attractive force act between them, and this is AB. So this AB determine whether it show positive deviation or negative deviation. What is positive deviation? Positive deviation means having more vapor pressure than what we expected from the Raoult's law. So what is the possible reason behind? What is the condition in which some liquid show more vapor pressure as compared to the other liquid? Obvious, when the force of attraction between the two liquid is less, right? When the force of attraction between the two liquid is less, then their escaping tendency is more. And what is vapor pressure, beta? What is vapor? That is how easy liquid converted into gaseous phase. This is called all about the vaporization or vapor. That if the more liquid is converted into gas, then it will show it will more vapor will be produced, and it will again give more vapor pressure, right? So if the force of attraction between the solute, this is solute, and force of attraction between the solvent is much more as compared to the force of attraction between solute and solvent, or we, in other words, we can also say that if the force of attraction between the solute and solvent is less as compared to solute and solvent, then escaping density in solution is higher in as compared to the pure component, right? Pure component like solute or solvent. As a result of this, more vapor will be produced and we get the positive deviation. So I hope, is it clear to you? Yes, there is no problem in this, Nabita. It is very much clear to you. Yeah, yani for such deviation, PA is greater than P naught A into XA and PB is greater than P naught B into XB. And hence we can say that the total pressure is greater than P naught A XA, P naught B XB. So this is how we can actually find out the positive deviation. Which solutions show positive deviation and which solutions show negative deviation. I hope this is clear to you. Okay. For such type of solution, we know that in case of ideal solution, delta H of mixing and delta V of mixing is equal to 0. But non-ideal solution, if they show positive deviation, it means delta H of mixing is greater than 0. What do you mean by this term? Delta H of mixing is greater than 0. Greater than 0 means, beta, it is endothermic, or it required energy, or it absorb energy. So as the new bond formed are weaker, okay, here the new bond formed not AB. So the new bond formed are weaker and energy is absorbed. Or we can say that in this case, delta V of mixing is also greater than 0. Why? Because there is increase in the volume. There is a increase in the volume because more vapor will be produced, escaping tendency will be more. So we can say that there is increase in the volume. So for the positive deviation, both delta V and delta H is greater than 0. Right. Now, let's move to the next thing, that is a graphical representation of non-ideal solution. So how we'll represent the positive deviation through a graph. So this dotted line represent the ideal behavior of the solution. So in positive deviation, pressure increase than what we expected. For similar, if I'm talking about PA, then the pressure increase from this point P naught A to this, right? This will be okay. So this is the increase in the pressure for A. Similar for B, this is the increase in the pressure. This solid line represent, right? And this dash line represent the ideal solution. Similar, if the PA and PB increase, then total pressure also increase, then we'll get total pressure like is this. Okay, so this is the graph of the solution showing the positive deviation from the Raoult's law. So this one is very important, beta. What are the examples, right? So this one is very, very important. Very important. What are the example of the positive deviation, right? So ethanol, water, ether and acetone, carbon disulfide and acetone, carbon tetrachloride methanol, cyclohexane and ethanol, water and methanol, carbon tetrachloride and benzene, carbon tetrachloride and toluene, and acetone and benzene. So these all are the example of positive deviation in which the force of attraction between the solute and solvent is less than what we expected in case from the Raoult's law. Okay, so these all are the example of positive deviation. Now, on the similar basis, beta, what are the negative deviation? So we know that for the solution, for the negative deviation, the vapor pressure comes out to be less than what we expect from the Raoult's law. So in such a mixture, what the cause behind this, beta? Obvious, the force of attraction between the solute and solvent is more as compared to force of attraction between solid solute and solvent solvent, because only in this thing, this category, only this thing will be happen. Why? Because if the force of attraction between the solid and solvent is more, then it is very difficult to escape, or we say escaping tendency decrease. So due to this, less vapor will be produced, or we can show that it will produce the negative deviation, that is the vapor pressure comes out to be less than what would we expect from the Raoult's law, right? So this is very much similar. Similar, delta H for the mixing is less than 0. It means heat is evolved due to formation of the strong bond. Delta V is also less than 0 because there is a decrease in the volume. So this is also the graphical representation. बिल्कुल similar है उसकी तरह जैसे हम लोगों ने positive deviation का पढ़ा. Just difference क्या है बेटा? यहाँ पे देखो सब कुछ हमने नीचे कर दिया, उसमें कर्व को ऊपर कर दिया था, वेपर प्रेशर इंक्रीजेस, इसमें हमने सबको क्या कर दिया है, नीचे नीचे कर दिया है, राइट? सो इट इज वेरी मच सिमिलर टू द positive deviation. Now, what are the examples of positive deviation? Like acetic acid, methanol, acetic acid, pyridine, acetone, aniline, acetone, chloroform, benzene, chloroform, water, hydrochloric acid, water, nitric acid, etc. These all are the example of negative deviation, right? Okay. Now, so this chart is very important. This table is very important because in this we are going to compare ideal solution and non-ideal solution. And further we can compare non-ideal solution into two types. That is the ideal solution. Sorry, that is a positive deviation and the negative deviation. Okay, so we all know what is ideal solution. We already revised this thing. That is which obey Raoult's law under the entire condition is known as ideal solution. For ideal solution, delta H of mixing is equal to 0, delta V of mixing is also is equal to 0, and delta G comes out to be negative, right? Similar non-ideal solution which do not obey Raoult's law. So if they do not obey Raoult's law, then what to happen? Either it show deviation more than what we expected or less than what we would expected from the Raoult's law. So on the basis of this thing, we further classify non-ideal solution into two types, that is a positive deviation and the negative deviation. So positive deviation means what, beta? What do you mean by the term positive deviation? In positive deviation, there is a very negligible amount of force of attraction between the solid and solvent. As a result of this, more escaping tendency is present and more vapor pressure will be produced than what we expected from the Raoult's law. Example of such kind of solution are ethanol, water, and ether acetone. So we already discussed, just revise this. Okay, and the similar basis, what is negative deviation beta? It means that in this, the vapor pressure comes out to be less than what we'd expect from the Raoult's law, and delta G and delta V volume is equal to 0, or we say exothermic, right? Or in this, intermolecular force of attraction between the solid and solvent is more. As a result of this only, less vapor will be produced, escaping tendency is less. So this is the comparison between the ideal solution and the non-ideal solution. So I hope this is very much clear to you all. Yes, beta. Anyone having any kind of doubt? No? Is it clear to everyone? That is what is the difference between the ideal, non-ideal, or we further classify non-ideal as positive and negative division, right? So now one important thing is here, and this is azeotrope. So what is azeotropic mixture? So these are the very important topic, and try to understand better. After this, we are going to solve some questions related to this topic, right? So what is azeotropic? So if someone asks, what do you mean by this term, azeotropic? Then what's your answer, beta? So a mixture of two liquid, or we say it is a binary solution, which boils at constant temperature, just like a pure liquid. It means a mixture of two liquid. It may be either it will be alcohol or water, anything between the two liquids. So a mixture of two liquid which boils at a constant temperature and distilled over, right? And distilled over without any change in composition, whether it is present in a vapor form or is it present in a liquid form. So their composition remains same throughout. So a mixture of two liquid which boils at a constant temperature and distilled over without any change in composition is called azeotropic mixture, right? It's called azeotropic mixture. So this is called azeotropic mixture, right? I hope is it clear to you? Yeah. Now, azeotropic mixture are of two types. That is a minimum boiling azeotrophs and the another is maximum boiling azeotrophs. What do you mean by this term minimum boiling azeotrophs? And their examples are very much similar to the positive deviation. So if you remember the example of which type of solution showing positive deviation, then you can easily remember minimum boiling azeotrophs. Yani, though the compound or the non-ideal solution which show positive deviation only can show such type of reaction, that is a minimum boiling azeotrophs, right? I hope this is clear to you. So what is the minimum boiling azeotrophs, beta? So these are the mixture of two liquids, right? Two liquids, boiling point of which is less than either of the two pure component, right? So these are the mixture of a two liquids having boiling point less than the either of the two pure component, and these are formed by the non-ideal solution showing positive deviation. It means the non-ideal solution which show positive deviation can form this type of mixture, right? So this is all about the beta minimum boiling azeotrophs, right? So these are the mixture of the two liquids. Okay, now on the similar basis, example of minimum boiling azeotrophs are similar to the non-ideal solution showing positive deviation. So the solution which showing the positive deviation are examples of, they are very much similar to the minimum boiling azeotrophs. So their example are same as the positive deviation. Okay, now what is maximum boiling azeotrope? What do you mean by this term maximum boiling azeotrope? So these are the mixture of two liquids, boiling point of which is more than either of the two pure components, and these are formed by the non-ideal solution showing a negative deviation. So these are the maximum boiling azeotropes, right? So these are the mixture of two liquids boiling point of which is more than either of the two pure component, and these are formed by the non-ideal solution showing the negative deviation. I think this is clear to you. What is maximum boiling azeotropes? Okay. So just remember one important note here. Minimum boiling agent drops shown by the positive deviation, the solution which show positive, and the maximum boiling agent drops are shown by those solution which show negative deviation from the Raoult's law. So these are the some azeotropic mixtures that are the example. For example, which will form minimum boiling agent drops and form maximum boiling agent drops, like H2O and HNO3. So these are the example of negative deviation, because in this the force of attraction between the solute and solvent is very large as compared to force of attraction between solid solute and solvent solvent. So H2 and HNO3. So this will show very large force of attraction. So here the composition, that is mass percentage of B, is given 68%, right? And the A is given 373. Boiling point of B is given. This is the temperature of A and B, right? So the temperature of A is what? That is temperature 373, we all know. Boiling temperature of water is 100 degrees Celsius, and this is 188 degrees Celsius. So azeotropic is 381.6. So these all are the example of maximum boiling isotopes, where the first one, that is H2O2 and ethanol, H2O plus heptanol, chloroform and methanol. These all are the example of minimum boiling agent, right? So this is all about this. Now we are going to solve some concept-based question, which is basically from the Raoult's law, ideal solution, non-ideal solutions, and positive and negative deviation. So this question is totally based upon the Raoult's law. That is the Raoult's law of liquid into liquid solution, or we say Raoult's law of volatile solution. So let's see the question and try to solve this question, okay? Because this is very important question. These type of questions are really generally asked in your examination. So try to observe the important concept here and try to solve this question as much as you can, okay? So let's start with the question. What the question given, beta? In this question, the question asks you, heptane and octane form an ideal solution. Okay, we all know that heptane and octane form ideal solution. At 373 Kelvin, the vapor pressure of the two liquid components are given. So vapor pressure of the two liquid components are already given. One is PA. If I'm talking about PA, it is 105.2 kilopascal. And if I'm talking about PB, it is equal to 46.8 kilopascal. Okay. What will be the vapor pressure of a mixture of 26 gram of heftane and 35 gram of octane? So in this question, they're asking, what will be the vapor pressure of the mixture of a 26 gram of heftane and 35 gram of octane? So these are the question. So what you have to do, beta, let me show you example, and this try to understand with the each step by step, so that you able to solve more and more question related to this topic only. Okay. So first of all, you have to calculate the number of moles of octane. So we all know that number of moles of octane means what? That is mass upon molar mass. So mass is already given, that is 35. And what is octane, beta? So octane having C8 and H18. This is the formula of octane, na? So this is octane. So C8H18. So molecular mass comes out to be 114. So just divide mass upon molecular mass. So we get the number of mole, that is 0.307 mole. Okay. Similar, if I want to calculate the number of mole of heptane, so it comes out to be 0.26 mole, because 26 mass of heptane is given divided by the molar mass. So it will comes out to be 0.26. Now, we all know that how to calculate mole fraction. So if you want to calculate the mole fraction of octane, then how will you calculate, beta? We know that the mole, how to calculate mole fraction. Yeah. So mole fraction of octane is equal to number of mole of octane divided by the total number of mole, that is Na plus Nb. So here Na is given and Na plus Nb is also given. So we can calculate the mole fraction of the octane. Now, if we know the mole fraction of octane, then we also know the mole fraction of B, that is heptane. How? That is 1 minus 0.541, right? So we can calculate this by 0.458. This comes out to be 0.458. Okay, so this is the mole fraction of B. Now, from the Raoult's law, these two values are given. That is the vapor pressure of the pure heptane, that is P naught A and P naught B. Okay. Now, in the mixture of 26 gram of heptane and 35 gram of octane, what is the vapor pressure of the heptane? So we know from the Raoult's law that is PA is equal to P naught A into XA and PB is equal to P naught B into XB. Right. So vapor pressure of heptane, that is PB, is equal to nothing but P naught B into XB. So what is P naught B here, beta? 105.2 kilopascal. And what is XB? 0.458. So it comes out to be 48.18 kilopascal. So it comes out to be 48.18 kilopascal. On the similar basis, if you want to calculate the vapor pressure of octane, okay, so what you have to do, beta? Pa is equal to again P naught A into XA. So P naught A also here is 46.8 and XA is equal to 0.541. So it comes out to be 25.32 kilopascal. So what is the total pressure of the mixture, beta? We know that total pressure is nothing but equal to Pa plus Pb. So what is Pa here? 48.18. What is Pb here? So, sorry, PB here is 48.18 and PA here is 25.32. So, by doing this calculation, we can calculate the total vapor pressure of the mixture, right? And this comes out to be 73.5 kilopascal. So, I hope this is very simple question and very important question as well, because this type of question they generally ask in your examination, right? So this is one of the very important question, totally based upon the Raoult's law for volatile solute. Okay, and this question is asked in your examination. Okay, so I hope you understand this question and you have no doubt related to this question. Any doubt better related to this question, you can ask me. Okay, now try to solve this question, because this question is very important as well as very easy type of question. So you have to calculate the amount of benzoic acid required for preparing 250 ml of 0.15 m solution in methanol. So you have to calculate the amount of benzoic acid. Here molarity is given, volume is given, and the name of the solute is given. So you have to calculate the amount of benzoic acid, that is amount of the solute. So I'm giving you a 1 minute for this question. Try to solve this question. Okay. Then I'm going to discuss the solution of this question if you face any difficulty in this question. Right. So just try to solve this question till I take just some water. Till just try to solve this question. I'll give you 1 minute for this question. After this, I'm going to explain you how to solve this question. Right. Okay. Yes. So I hope you all try this question and get the answer. Okay. So let me solve this question for those who are unable to solve this question. This question is very easy, right? First of all, you need to write the formula of molarity, because this question is based upon molarity. This capital M beta. Okay, this capital M represent molarity. So we know that what is the formula for finding molarity beta? Molarity is nothing but mass of the solute. Mass of solute divided by molar mass, right? Mass of the solute divided by molar mass into 1000 divided by volume of the solution. Divided by volume of the solution, right? So this is the molarity, mass of the solute divided by molecular mass into 1000 upon volume of the solution. So what is the mass of the solute? So in this question, you have to calculate mass of the solute only, right? So what the question asks? Mass of the solute. You have to calculate mass of the solute. So what is the molarity here, beta? Molarity is given, that is 0.15. Mass of solute you have to find. What is the molecular mass of this? C6H5COH. This is called benzoic acid. So how will you find the molecular mass of benzoic acid, beta? Okay, so this is 12 into 6, right? Plus 5 plus again 12 plus 32 plus 1. So just calculate this. 12 6 the 72 plus 5 plus again 12 plus this is 32 and 1, that is 33. So just add this all. What you will get, beta? On adding, what you will get? That is 72 plus 5, right? Plus 12 plus 33. Okay, so it comes out to be 122. So the molecular mass comes out to be 122 gram per. So this is the molecular mass of benzoic acid. So just put here that is 122. Okay, this is 1000. What is the volume of the solution, beta? That is 250 ml. So this is 250 ml. Just solve this. This is cancelled by 4. You have to calculate x. So x comes out to be 0.15 into 122 divided by 4. Right. So just solve this. What will get, beta? You will get 4.57. That is 4.575 gram. So this is the amount of the solute. Right. So which one is the correct option? That is B, 4.57. So this is absolutely correct answer for this question. Okay. So this is very simple and this is very important question which is totally based upon the molarity. And how will you identify, beta? This question is based on molarity by this value only, 0.15 m. 0.15 m means only that is 0.15 mole present in 1 liter of the solution. So by using the formula, you can easily calculate what amount of solute that actually present in this, in what amount of benzoic acid that is dissolved in 250 ml to make this molarity of solution, right? Now, let's move to the next question. In this question, an antifreeze solution is prepared from 2 to 2.6 gram of ethylene glycol and 200 gram of water. Now, if the density of the solution is this, then what shall be the molarity of the solution? So you have to calculate in this question also, you have to calculate the molarity and density is given. So whenever the density is given, we can use the formula of density to find volume, because in molarity we want volume. Now we require volume for solving the question, but in this the volume is not given. So by using the density we can easily calculate volume. So let me first write the formula of molarity so that we can identify what we need, what data we need to calculate this molarity, right? So what is the formula for molarity? That is again mass of the solute, mass of the solute divided by molar mass multiply by 1000 and divided by volume of solution. Right. So molarity is nothing but mass of the solute upon molar mass into 1000 upon volume of the solution. Okay. I hope this is clear to you. Good. Now, in this question, mass of the solute is given. Molar mass is also, we are able to calculate this, right? And only one thing that we need, that is the volume of this solution. This thing is missing here, right? So we need to calculate this thing only. After this, we can easily solve this equation. So let's see how will you calculate the volume of the solution. We know that density is what? Density is nothing but mass upon volume. So this is the mass of the solution upon volume of the solution. Okay. Now, what is the mass of the solution here, beta? What is the mass of the solution here? Can anyone tell? What is the mass of the solution? Mass of the solution means what? That is mass of the solute plus mass of the solvent. This is only the mass of the solution. So here, ethylene glycol, which is the solute, is given to 2.6 gram. Also, mass of the solvent, that is the water, is also given 200 gram. So we cannot calculate MS. Yes, we can definitely calculate MS, right? So what is MS beta? MS comes out to be 222.6 and plus 200, right? 222.6 plus 200. So this is the mass of the solution. And what is density? It is given 1.072. So it comes out to be, can you calculate now? Can you calculate better now? What is the volume of the solution? That is 22.6, right? Plus 200. It comes out to be 422.6 divided by 1.0, and this is 72, right? So it comes out to be 394. So 394.21, and this is in ml, right? This is in ml. So this is the volume of the solution. Now what to do? Now we can calculate or not? Now we can calculate molarity or not? Yes, definitely. If you get the, if you get the volume, then we'll easily calculate. Just put this. Just put in equation A. Just put in equation A. So what is the equation A here, beta? This is molar mass. Mass of the solute is already given, 222.6. Molar mass is already given. What is the molar mass here, beta? You have to calculate, right? Ethylene glycol. How will you calculate, beta? C2H6O2. So this will be 12 into 2, 6 into 1 plus 32. So it comes out to be 24 and 6, 30, 32. That is 62. Right? It comes out to be 62. Just put this 62 here. This is 1000. And what is the volume? It is around 394.21. So just by solving this, that is 222.6 into 1000 divided by 62. So we'll get. So what we will get, beta? 222.6 divided, multiply by 1000 divided by 62, further divided by 394.21. We get the answer, that is 9.10. So the answer comes out to be 9.10 m. So which one is correct, beta? Tell me, which of the following out of these four options, which one is correct, beta? That is 9.1. This one. Okay. So option B is absolutely correct. So you observe how questions were coming, and in this such type of question we need to stabilize the relationship between what happened if the volume is not given and someone asks how to calculate molarity. Then we must know about the concept of density. If you know the concept of density, then you can easily calculate volume by just knowing the mass of the solution and the density of the solution, right? So these type of questions are really good, because in this question, by doing or by solving such type of questions, you get to know the idea. If one data is missing, if one data is not given, then how will you find the relation between this, and how easily and how precisely you can solve the question, right? So this is very, very important question. Now let's move to the next question, and this question is totally based upon ideal and non-ideal solution. So what the question asks, beta? Read out what the question asks. In this question, the question are asking if the two liquids A and B form minimum boiling azeotrophs. We already know there is a two type of azeotrophs, maximum boiling azeotrophs and the minimum boiling azeotrophs, right? Maximum boiling azeotrophs and the minimum boiling azeotrophs, right? So what is this minimum boiling azeotrophs and maximum boiling azeotrophs, beta? Can you give me example? Yeah, so we know that minimum boiling azeotrophs are shown by those having minimum boiling azeotrophs are shown by those which show what? Positive deviation or negative deviation? Tell me first. Positive deviation or negative deviation? So they are asking about minimum boiling azeotrophs. So minimum boiling azeotrophs are always shown by the positive deviation, right? So the solution showing the positive deviation, so such type of azeotropic mixtures like a minimum boiling azeotropic mixture. And we know that what is the reason for positive deviation, beta? The force of attraction between solute and solvent is less as compared to solute-solute and solvent-solvent, right? So if the force of attraction between the solute-solute and solvent-solvent is more as compared to solute and solvent, then it will show positive type of deviation or it form minimum boiling agent. So let's understand the options. So AB interaction are stronger? No, this is absolutely wrong. AB interaction are weaker than those of AA and BB? Yes, this one is very much, very much clear. Okay, so option D is the correct answer for this question, right? Now, let's move to the next question. And this question is also based upon the ideal, non-ideal solution. So what the question asks, Mita? So in this question, they're asking when the two liquids A and B are mixed, then their boiling points become greater than both of them. What is the nature of this solution? Just read this question once. When the two liquid A and B are mixed, two liquids, liquid A and liquid B are mixed, and their boiling points become greater than both of them. If they show, maximum boiling point, their boiling point is more, maximum boiling point, greater than both of them. What is the nature of this solution? Whether it is an ideal solution, it is a normal solution, negative deviation with the non-ideal solution, or the positive deviation. So beta, can anyone tell me in which the force of attraction is more? We all know that non-ideal having two type, positive and negative, or in negative deviation. In negative deviation, not only they having more force of attraction, that is the force of attraction between the solid and solvent is very much greater than what we expected from solid and solvent. Right. So if the force of attraction is more between the solid and solvent, then obvious it show higher boiling point. Right. It show higher boiling point. And as a result of this only, right. And as a result of this only, it will show such type of deviation. So what is the nature of the solution? That is a negative deviation with the non-ideal solution. Why, beta? Because in only negative deviation, the force of attraction between the solid and solvent is more. As a result of this only, they have a high boiling, right? I hope is it clear to you? Good. Now, let's see the next question. A binary solution of ethanol and N-heptane. Example of this type of solution. So you have to remember the example of positive and negative deviation. Then only you are able to predict the answer, right? A binary solution of ethanol and N-heptane. That is alcohol and N-heptane. As an example of whether it is a show ideal solution. No. Non-ideal solution with positive deviation, non-ideal solution with negative deviation, or unpredictable behavior. So the correct answer is because there is a hydrogen bonding in ethyl alcohol which is cut off and adding N-heptane. Hence it show positive deviation. So whenever we take two liquid like alcohol and hydrocarbon, or we say heptane, hexane, octane, nonane, it always show positive deviation, right? So this is also very important. Now, let's move to the next question. That is the negative deviation from the Raoult's law is observed in which one of the following binary liquid mixture. So you have to identify the option in which you observe the negative deviation. And you know very well that is what is the condition for the negative deviation. That is the force of attraction between solids and solvent is much more, so that the escaping tendency decrease, and they show what? Negative deviation, right? So what are the example, beta? Ethanol, acetone? No, ethanol and acetone show positive deviation. Benzene, toluene? No, it will show ideal behavior. Acetone and chloroform? Chloroform and bromoethane, and acetone and carbon disulfide. So only this option beta, that is C, acetone and chloroform, because in this only there is a force of attraction or is a hydrogen bonding, and this due to this force of attraction, dipole-dipole interaction, it will show negative deviation, right? So on mixing acetone and chloroform, dipole-dipole interaction takes place. Hence, it show negative deviation from the Raoult's law, right? So it will show negative deviation. Now, next question is, if ethanol dissolve in water, then which of the following would happen? So you have to dissolve ethanol, dissolve in water. So what happened, beta? First, absorption of heat and contraction of volume, liberation of heat and contraction of volume, absorption of heat and increase in the volume, or we say liberation of heat and increase in the volume. First of all, ethanol dissolve in water. So this is alcohol and water, right? So ethanol plus water form non-ideal solution, showing a positive deviation from the Raoult's law. Hence, that is delta H is equal to positive, and there is absorption of heat, that is delta V is positive. There is increase in the volume, right? So delta H is positive. There is a absorption of heat. So absorption of heat and increase in the water, right? So option C is absolutely correct. Option C is absolutely correct. Now, the next question that is asked related to this topic, that is, which one of the following binary liquid system shows positive deviation from the Raoult's law? So this question is also based upon examples of positive and negative deviation. So this is very important, beta. Always try to learn the examples of the different types of solution, whether it is show positive deviation or negative deviation, because many time questions were asking directly on based on the examples. So please tell me whether this is an example of positive deviation or not, whether it is an example of negative deviation or not. So these type of questions are generally coming. Okay, so it is very important you to learn the examples of positive and negative deviation as well, so that you can easily identify the option. Okay, so in this question, which one of the following binary liquid system shows positive deviation? We know that benzene and toluene are the ideal solution. Carbon disulfide and acetone, phenol and aniline show negative deviation. Chloroform and acetone also show negative deviation. Nitric acid and water also show negative deviation. So these three are showing negative deviation. And this will show ideal solution. So which one is left, beta? That is carbon disulfide acetone. So this carbon disulfide acetone showing positive deviation. I hope this is clear to you. Yes, beta. सबको समझ आया? Yeah. So this is totally based upon the examples of positive and negative. Now, next question. Which will form maximum boiling azeotrope? So you have to identify which will form maximum boiling azeotrope. So for to do this, we know that for maximum boiling azeotrope means what? Which show positive or negative deviation. So obvious, which show negative deviation. Anything which show negative deviation, right? So anything which show negative deviation will form maximum boiling azeotrope. So out of this, you have to identify which one is the maximum boiling azeotrope. Just remember this negative. So which one of the following is an example of negative deviation, beta? First, HNO3N solution. Right. So the first one, that is HNO3 and water, nitric acid and water. This will show negative deviation, vapor tendency decrease, and this will show only maximum boiling edge. Right. So I hope this is clear to you. Right. Okay. So these are the important questions based upon the ideal and non-ideal solution. So this question I'm going to you as a homework to try to solve this question. In next class, I'm going to solve this question as well. Till you can try this question. This is totally based on the Rawls law, right? So by using the Rawls law for the volatile solution, you can easily calculate this question. Okay, so try to solve this question as this is your homework question. Now, in this week, we what we covered so far, we covered a concentration defining term, basic terms, and the liquid and liquid solution. That is the Rawls law, and the ideal and non-ideal solution. In coming week, that is from tomorrow, that is from Monday, we are going to start colligative properties, right? So these colligative properties are very important, and many times they are come in your examination. Many questions in this chapter from this chapter solution chapters were directly from colligative properties. So colligative properties is going to be very important topic for you. So try to attend the class and try to understand the whole concept so that you can easily solve a question numerical related to the colligative properties, because the colligative property is totally numerical based chapter. In this chapter only numericals were coming in a PY previous papers, only numericals were coming from the colligative properties. But these properties are very important to understand. Once you understand the property, then you can easily solve the numerical. There is no, there is no much tips and tricks are present. So by easily just remembering the formula, you can easily solve the questions. Right? So this is your homework question. Try to solve this question. In next class, I'm going to check whether you do it wrong or right. Try to just solve this question. Okay. So let's meet in the next class. Till take care and try to read this. Whatever we covered so far, try to remember this. Try to solve this question.